Hello everyone, I welcome you all, and in this video we are going to discuss the numerical from your unit number 1, that is vector analysis, and this numerical is basically related with the finding the gradient of a scalar field. Now if you have any queries you can drop me a mail onto this my mail ID, and I will try to get you as soon as possible. Okay, now we will start with what is given to us and what is to be find out over there. Now the gradient of a scalar field is given by means of what? It is equals to that del V. This del is also said to be it shows you the maximum rate of space change in a given direction for its maximum magnitude. Okay, so since this given component v is expressed with this 3x square y plus 3y square z, and it is not associated with ax, ay and az component, so that's why we are not going to say it to be the vector field. So it is a scalar field, and since it is with the x, y and z component, so we have to write, or we have to find out the gradient for your Cartesian system, and gradient for Cartesian system is given by means of what? We have that to be the partial differentiation with respect to that x for your given v component along x component, then d by dy of your v field along ay component, and d by dz of your given v along az component. So that shows you what? It shows you the maximum space rate of change in x, y and z direction with respect to that x, y and z components. Okay, now we will have that differentiation. So we are going to put the values of that v over there. It is also said to be a Daba operator, that d by dx. Okay, so what is v? We have that v is equals to 3x square y plus, sorry, that is 3y square z plus 3y square z along x direction, then partial differentiation with respect to y for your given v, 3x square y plus 3y square z along ay direction, and partial differentiation with respect to z of your given v along az direction. Now differentiate that one, that is easier for you. So differentiation of this very first term with respect to x will be what now? So this 3 into x square. So x square have the derivative, that is equals to 2x. So that 3 into 2x will be what now? That will be 6x. That y will be as it is. That y will be as it is. So that will be 6xy. Now is there any x component over here? No. So that's why this second component will be what now? Second term will be what now? 0 along your x direction. Now differentiation with respect to y. So differentiation with respect to y over here will be what now? It will leave this 3x square as a constant as it is, and differentiation of that y with respect to y is what? That is equals to 1. Now differentiation of your second term with respect to y will be what now? So y square will be 2y, and this 2y into 3 will be what now? 6y z along ay direction, and this differentiation of second term with respect to z. So we have this value to be 0 over here since there is no z term, and over here, so 3y square will be constant, and derivative of this z with respect to z will be 1. So that's why we will have this term to be what now? 3y square along az direction. Okay, now we are going to rewrite that one. So very first term we have that to be the 6xy x cap. Then second term we have that to be the 3x square plus 6yz ay cap plus 3y square az cap. So this is what? This is the gradient of your given scalar field V. So we have found the gradient of a scalar field V. Now next is what? We have to find out that gradient at that given point P. And what is that point P? That we have to be P is equals to, okay, we will rewrite that one. Now we have to find out del V at given point P, which have the coordinates of 1, -2 and -1. Now we just have to put the value of that x, y and z within our term, this equation. So this 6 into x, x is what we have, that is to be 1, y we have given is -2, then x cap plus 3x square. So x is what we have. So we have that x is equals to 1 square plus 6 into y, that is -2, and then into z, z is again -1. So this is your second bracket, and lastly 3y square. So y we have that y to be what? Minus of 2 square into az cap. Now if you simplify that one, you will find the gradient del v at the respective points, that is 1, -2 and -1. So we have that answer to be what? Minus 12x cap plus this 3 into this -2 -1, that will be +2, +2 into 6 will be 12, and 12 plus 3, so that will be 15, plus 15 ay cap, and this -2 square is what? 4, so 4 into 3 will be what? 12 az cap. So this is what? Gradient of a scalar field, which is basically a what? This is a vector field. If you see what is given to us, we have been given with this simply V having no ax ay component, and what is our final answer? So that is what? The gradient of a scalar field, which is a vector quantity which have some magnitudes along x, y and z direction, having components ax, ay and az component. So this is our final answer. Okay, thank you.